And this is the 2000 AIME 2 problem 9. Let's have a view of this problem. Given that z is a complex number such that z plus 1 over z is equal to 2 cosine 3, find the least integer that is greater than z to the 2000 plus 1 over z to the 2000. Okay, so let's first work with what we have. Z plus 1 over z is equal to cosine 3. And then now multiplying by z and bringing the 2 cosine 3. And then multiplying by z and bringing over the 2z cosine 3 gives us z squared minus 2z cosine 3 plus 1 is equal to 0. And now this is the form of a quadratic, so we apply quadratic formula to get 2 cosine 3 plus or minus the square root of 4 cosine squared 3 minus 4 over 2. Now 4 cosine squared 3 minus 4, if we factor out a root 4, we get cosine squared 3 minus 1. But that's not as helpful because we don't know any trig identities to deal with that. So instead we can factor out a root negative 4. And doing so will give us root 1 minus cosine squared 3. And this is way better because this is just sine 3. So doing that gives us 2 cosine 3 plus or minus the root negative 4 is just 2i. And this is just sine 3. 2i sine 3 over 2 simplified to get cosine 3 plus or minus I sine 3. Okay, and then now to find z to 2000 plus 1 over z to 2000, it doesn't matter if we take cosine 3 plus I sine 3 or cosine 3 minus I sine 3. We'll get the exact same answer, and try to prove that yourself. It just has to do with the geometric interpretation of the roots of unity. But anyways, just taking cosine 3 plus I sine 3, and exponentially to the power of 2000, applying de Moivre's theorem, this gives us cosine 6000 plus I6 sine 6000, and then we can subtract 16 360s to give us 240, right? So this is just cosine 240 plus I sine 240. Okay, and then it's going to be easier to deal with this in the long run in exponential form because we have to take the reciprocal. So we just do that e to 4 pi I over 3 plus e to 2 pi I over 3. Because that's just e to the 2 pi I minus 4 pi over 3, which is 6 pi I over 3 minus 4 pi I over 3, which is 2 pi I over 3. And then doing this will give us cosine 240 plus I sine 240 over here is just by trig, negative 1/2 minus root 3 over 2i. Okay, and then this thing over here is just cosine 120 plus I sine 120, which is equal to negative 1/2 plus root 3 over 2i. The root 3 over 2i's cancel, we get negative 1, and find the least integer that is greater than this, that's 0. And we are done.